This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. As some of you know, due to caucus votes at 3 p.m., I'm going to try to keep my introductory remarks brief and ask to submit the rest for the record in order to get witness testimonies in as quickly as possible. The chairwoman and ranking member of the full committee have also agreed to submit their statements for the record. As we have previously discussed in this subcommittee, Americans depend on the data and services provided by the National Oceanic and Atmospheric Administration, or NOAA, and the National Weather Service every day. Earlier this Congress, in this subcommittee's hearing on the NOAA fiscal year 2020 proposed budget, we heard from Acting Administrator Dr. Jacobs that the U.S. is not currently the global leader in weather forecasting. Considering how important accurate weather forecasting is to all Americans, this is extremely concerning. The National Integrated Drought Information System Reauthorization Act, which was signed into law in January 2019, directed NOAA to establish the Earth Prediction Innovation Center, or EPIC. EPIC is tasked with creating a collaborative, community-driven global weather research modeling system. The system will be publicly accessible, allowing those outside of NOAA to access and contribute to a community-developed model. At today's hearing, I look forward to a discussion with our distinguished panel of experts about how EPIC will leverage the skills and expertise across the public, private, and academic sectors of the United States weather community to bolster modeling and forecasting. Since EPIC is still in its infancy, this hearing will provide a timely opportunity to discuss the future of its organization, management, and governance, and examine each sector's vision and short and long-term goals for EPIC. I cannot overstate the importance of improving U.S. weather modeling and prediction capabilities. EPIC represents what some experts in the weather community have claimed is America's last chance to get this right and restore our leadership in global weather prediction. I look forward to today's discussion about how EPIC is going to accomplish this. Thank you. The chair now recognizes Ranking Member Marshall for an opening statement.
Thank you for holding this hearing. I want to thank our witnesses for appearing before the subcommittee, especially Dr. Jacobs, who is in front of all of us now for the third time this year in Congress. And thanks for all of you on the panel for sharing your perspectives. Weather prediction is something that affects the constituents of every member up here, from the fields of Kansas to the Outer Banks of North Carolina. Anticipating the strength and conditions of the next weather event can save lives and property, as well as be the difference between a profitable year for a farmer or a catastrophic loss. I'm proud to say the Science Committee acted decisively last Congress by passing the Weather Research and Forecasting Innovation Act, the Weather Act, and the National Integrated Drought Information System Reauthorization Act. The Weather Act was first authorizing legislation to address weather forecasting in 25 years and prioritized improving weather data, modeling, computing, and forecasting. I'd like to extend my gratitude to Ranking Member Lucas for introducing what is now a law and for his continued leadership on this issue. The NIDIS Reauthorization Act established the Earth Prediction Innovation Center, EPIC, the topic of our hearing today. EPIC, when completed, will crowdsource the expertise of the private sector and the research communities to improve our forecasting models. This aligns with Congress' vision for the program by leveraging the weather enterprise to provide knowledge and skill on numerical weather prediction. The federal government should be doing more to utilize the resources of private companies and university researchers who are often the leading sources of innovations. In addition to having world-class facilities and mines, private companies and academics are extremely flexible in research development and cost-effective in their methods. It is in the best interest of Kansas farmers, ranchers, emergency personnel, and everyday residents to have more accurate forecast. And EPIC is an important step in the improvement of our forecasting ability. In 2012, Hurricane Sandy caused nearly $70 billion in damage as it made landfall in Cuba and the northeast coast of the United States. This was the catalyzing weather event which caused Congress to examine how we could improve weather forecasting. We don't know when the next superstorm will be, but it's my hope that through EPIC, NOAA and the National Weather Service will be fully prepared to predict, respond, and recover from the next severe weather event. While NOAA has taken the initial steps to implement EPIC, we must see a stronger sense of urgency moving forward because it's designed as a community approach to weather prediction and modeling. I look forward to hearing how Dr. Masse and others have been involved in implementing this center and getting their feedbacks on how to ensure a successful and timely completion. Thank you, Mr. Speaker, and I yield back.
If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Our first witness is Dr. Neil Jacobs. He is the Assistant Secretary of Commerce for Environmental Observation and Prediction, performing the duties of Undersecretary of Commerce for Oceans and Atmosphere. Prior to joining NOAA, Dr. Jacobs was the Chief Atmospheric Scientist at Panasonic Avionics Corporation. He was also the chair of the American Meteorological Society's Forecast Improvement Group and served on the World Meteorological Organization's aircraft-based observing team. Dr. Jacobs has a master's and doctoral degree in atmospheric science from North Carolina State University. Our second witness, Dr. Cliff Masse, is a professor of atmospheric sciences at the University of Washington. His specialty is numerical weather and climate prediction and the meteorology of the western United States. Previously, Dr. Masse was a faculty member at the University of Maryland's Meteorology Department. Dr. Masse is a fellow of the American Meteorological Society, a member of the Washington State Academy of Sciences, and has published over 120 papers. Dr. Masse received his PhD in atmospheric sciences from the University of Washington. Welcome. Our third witness, Dr. Peter Neely, is an IBM Distinguished Engineer and Director of Weather Forecasting Sciences and Technologies for the Weather Company. He specializes in developing state-of-the-science technologies in weather forecasting for public use and weather-dependent markets. Dr. Neely worked as a scientist at the National Center for Atmospheric Research and the chief scientist at Weather Services International Corporation. Dr. Neely recently served on NOAA's Science Advisory Board's Environmental Information Services Working Group. He was a longtime member and chair of the American Meteorological Society's Committee on Weather and Forecasting. Dr. Neely holds a master's degree and a PhD in meteorology from MIT. Welcome. Our final witness, Dr. Thomas Aleni, thank you, is the director of the Joint Center for Satellite Data Assimilation, a research center based on a multi-agency partnership between NOAA, NASA, the U.S. Navy, and Air Force. He is responsible for the mission to accelerate and improve the quantitative use of satellite data in weather, ocean, climate, and environmental analysis and prediction systems. Dr. Auligné has held research positions at the National Center for Atmospheric Research, the European Center for Medium-Range Weather Forecasting, and Météo France. Dr. Auligné earned a master's in meteorology and a PhD in atmospheric physics in France. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you all have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. Jacobs.
Good afternoon, Chairman Caston, Ranking Member Marshall, and Ranking Member Lucas. Thank you for the opportunity to testify at this hearing. NOAA is entrusted with the responsibility to provide environmental information and prediction to the public to enable informed decisions on a range of phenomena spanning a broad spectrum of temporal and spatial scales. Part of NOAA's core mission is to protect lives and property and to safeguard the national economy. With such an important task, it is imperative that NOAA provide accurate and timely weather information. We strive to produce the best weather forecast in the world, underpinned by cutting-edge research, collaborative external partnerships, and thousands of dedicated scientists. Following Hurricane Sandy, Congress provided supplemental funding for NOAA to take first large step towards increasing computing capacity and improving its global forecast models. The desire to improve NOAA's weather mission culminated in congressional interest and the passage of the Weather Research and Forecasting Innovation Act of 2017. This groundbreaking legislation contains a number of important directives for NOAA, including focusing transitioning research to operations, sub-seasonal and seasonal weather forecast improvement, and satellite data innovation. Since coming to NOAA, implementing the Weather Act has been my top priority. One section in the Weather Act I would like to draw attention to is the mandate to make NOAA's numerical weather prediction code publicly available. While NOAA has complied with this directive in spirit, it has been unable to fully implement it. The existing version of the code is unique to NOAA computers. This means that while the public would have access to the code, without access to NOAA's internal computers, they would not be able to actually run the model. To solve this problem, NOAA needs a strategy to allow for greater accessibility by the public. To achieve this, NOAA will need to port its weather model code to commercial cloud where it can be hosted by one or more providers. Making NOAA's model code available to the public will allow external world-class scientists and researchers the opportunity to collaborate on new improvements. and this is a new way of thinking. Instead of keeping research and development inside of NOAA, the entire weather enterprise will be able to work with us to improve our modeling system, thereby accelerating advancements to our mission of protecting life and property. This strategy is the core principle of NOAA's new Earth Prediction Innovation Center. Building on the tenets of the Weather Act and recently authorized in the National Integrated Drought Information System Reauthorization Act of 2018, EPIC will serve as the core research to operations to research hub for building and maintaining a community modeling framework. EPIC's innovative structure will link scientists and software engineers in academia, the private sector, and partner agencies with research, development, and operational activities inside the agency. Doing so will help accelerate model improvements, enhancing NOAA's ability to provide accurate warnings of weather-based threats and helping to reestablish the U.S. preeminence in numerical weather prediction. Once integrated into the infrastructure of NOAA, EPIC will be used with the Unified Forecasting System to improve forecast skill of NOAA and other modeling initiatives such as climate and ocean models. EPIC's public accessibility through highly scalable commercial cloud-based HPC architecture will enable external research partners to develop, test, and provide feedback on the American modeling system. Structured as a virtual center, EPIC will also manage model evaluation, source code, and user training. Where appropriate, NOAA will look to partner with other federal agencies and academia to further this initiative. In the President's FY20 budget proposed $15 million for EPIC. NOAA recognizes that this importance of the EPIC program has already started implementing several steps to plan for its future. Last month, NOAA held an industry day to engage outside collaborators ranging from universities to cloud vendors. NOAA has also issued a request for information on governance structure of the program itself and has conducted extensive market research with external stakeholders. With adequate funding, NOAA looks forward to issuing a request for proposals and moving forward with this critical program. Chairman Caston, Ranking Member Marshall, Ranking Member Lucas, and members of the subcommittee, thank you again for inviting me to participate today, and I would be pleased to answer any questions you may have.
Thank you. Dr. Masse, you're recognized.
Thank you. Good afternoon, Chairman Caston, Ranking Member Marshall, members of the subcommittee. My name is Cliff Masse, and I am a professor of atmospheric sciences at the University of Washington. The U.S. is behind numerical weather prediction, and we are not catching up. NOAA's global model is either third or fourth in skill behind the European Center, the UK Met Office, and often the Canadian model. The U.S. has the leading weather research community in the world, and our nation invests heavily in weather prediction. We should be far ahead, consistent with the state of the science, but we are not. And our global model is not the only problem. U.S. weather prediction trails in other crucial aspects, including high-resolution ensembles and model post-processing. In 2012, the nation became aware of the problem during Hurricane Sandy, and Congress responded with additional funds. 7 years later, objective numbers show that we are not catching up, and the cost to the American people of this stagnation is huge. State-of-the-science forecasting will save lives, greatly aid the U.S. economy, and serve as the first line of defense for severe weather. So why is the U.S. failing in this crucial arena? The causes are duplication of effort, poor organization, and lack of leadership, plus insufficient computer resources. The enormous weather research resources of the United States are spread over too many modeling systems. NOAA has 3 groups working on such models: the Environmental Modeling Center, and the NOAA's ESRL and GFDL labs. NASA and the Navy have both developed both global and regional models. The Air Force has acquired a foreign modeling system, and the National Center for Atmospheric Research, which encompasses the academic community, has developed another global modeling system in addition to the well-known WRF model. The U.S. research community has mainly worked with NCAR's weather models, and NOAA has used its own. They are not generally working together, and thus NOAA has been cut off from the innovations and energy of the U.S. academic community. Such a division of effort has undermined U.S. weather prediction, resulting in a large number of subcritical inferior efforts. But there's more. NOAA has been starved for computer resources, crippling research and testing, and blocking the operational application of promising approaches. My analysis, supported by colleagues in NOAA, is that the National Weather Service could effectively use 100 times its current computer allocation. All of these problems can be turned around quickly if our nation reorganizes how we develop, test, and run numerical weather prediction models. And the key to it all is bringing resources and personnel together in one national effort. EPIC can be a big part of the solution. EPIC must be the center, become the center of U.S. model development and testing, and resources should be concentrated there. It must be a physical center located outside of NOAA and serve all agencies and groups in the nation. EPIC needs resources, independence, autonomy, stability, and most importantly, responsibility to deliver the best modeling system in the world. It must be an exciting center of discovery, science, and technology that will attract the best scientists and our best students. EPIC needs sufficient computer resources for development and testing. It must entrain the efforts and capabilities of the U.S. research community, most importantly, that of the National Center for Atmospheric Research. Finally, EPIC must develop and support a national community model that is freely available to the nation. EPIC can easily fail if it is not given primary responsibility and resources to create the best weather prediction system in the world. It will fail if its goals are too narrow or designated to serve a single agency. Our nation was the first in numerical weather prediction, but we threw away leadership by dividing our efforts. It is time, through EPIC, to combine the national resources and rationalize how we develop forecast models with extraordinary benefits to the American people. Thank you very much.
Dr. Neely, you are recognized for 5 minutes.
Thank you, Chairman Caston, Ranking Member Marshall, and Ranking Member Lucas, and all members of the subcommittee. Thank you for the opportunity to address the subcommittee today. My name is Peter Neely, and I am the Director of Weather Forecasting Sciences and Technologies at the Weather Company, part of IBM. I oversee a team of scientists and engineers that develop a broad suite of technologies that are used to create and distribute weather forecast products and services for both the U.S. and the rest of the world. The U.S. is fortunate to have the most vibrant weather enterprise anywhere in the world, with deep partnerships between federal, academic, and private sectors creating and delivering services for the nation. The Weather Company and IBM are proud to be active contributing members to that weather enterprise. Numerical weather prediction, or NWP, is the foundational technology used to create nearly all weather forecasts today. At the Weather Company, we employ many of our own numerical weather prediction models, but are also heavily dependent on the forecasts from numerical weather prediction models by NOAA and others. Because of that dependency, the Weather Company has deep interest in the quality of numerical weather prediction forecasts produced by NOAA. Accordingly, I actively participate in numerous advisory boards, committees that discuss and make recommendations on means of improving numerical weather prediction capabilities for the nation, including the Earth Prediction Innovation Center. The workshop for the community workshop for the Earth Prediction Innovation Center held this past summer gathered nearly 300 stakeholders from inside and outside of the federal government to inform NOAA and the community on early ideas for implementing EPIC. And a summary report of those findings, I believe, was released just yesterday by NOAA. The U.S. has a rich history in developing and operating numerical weather prediction systems that date back to the 1950s. Today, numerical weather prediction capabilities are developed and deployed in numerous places, including NOAA, the Department of Defense, the Department of Energy, NASA, National Science Foundation-funded institutions, academic organizations, and the private sector. Each corner of this numerical weather prediction community has created modeling capabilities tailored to the mission of each one of those individual institutions. Unfortunately, there is no overarching national strategy guiding the organization and interaction of these activities, which has led to less than optimum efficacy in any one of them. Further, there is no obvious existing place within the enterprise where such a strategy might be formulated and executed. As a result, there is a very broad set of NWP capabilities across the nation, some of them good, but few of them as good as they could be. In fact, when compared to models developed by international counterparts in Europe and the UK, our global numerical weather prediction systems from NOAA and other members of our national enterprise are materially less accurate and have been for decades. As a result, our nation is significantly less prepared and less resilient to the adverse impacts of weather and climate than we could be. Today, I wish to convey 4 key points to the subcommittee. First, under the leadership of Acting Administrator Jacobs and his vision for EPIC, we have before us a generational opportunity to address the shortcomings of our nation's NWP capabilities and elevate them to the world's best. Second, EPIC, as proposed by Dr. Jacobs, envisions the creation of a state-of-the-science institution for the community and by the community, where the numerical weather enterprise collaboratively works together using a common framework of tools and technologies. This would enable the most effective and efficient development of advanced numerical weather prediction capabilities in support of both NOAA and all the other numerical weather prediction stakeholders across the nation. Third, to execute this vision, NOAA must construct EPIC as a semi-autonomous and externally managed national institution that will establish, catalyze, organize, and manage a large and diverse scientific and technical community, collaborative working towards the betterment of NWP. NOAA would be a major constituent in the EPIC community, participating in both its governments and scientific endeavors, but would only be one of the many stakeholders drawing value from its accomplishments. Finally, in order to achieve this vision, numerical weather prediction stakeholders across the federal government must embrace and actively participate in EPIC. As outlined in my written testimony, I think Congress plays an important role in fostering and incentivizing such participation, as well as in otherwise helping ensure the long-term success of EPIC. Thank you for the opportunity to address the subcommittee today, and I also look forward to your questions.
Dr. Auligné, you are recognized for 5 minutes.
Good afternoon, Chairman Kasten, Ranking Member Marshall, Ranking Member Lucas, and members of the subcommittee. Thank you for the opportunity to testify today. I am Dr. Thomas Aleni, Director of the Joint Center for Satellite Data Assimilation at the University Corporation for Atmospheric Research. As a trained meteorologist, I care deeply about improving the quality of our weather models, which help build a weather-ready nation and save lives and property. My experience in academia and operational centers gives me a unique perspective on the so-called valley of death, separating research and operations. For more than 30 years, weather prediction in the United States has been trailing behind other international centers, most notably the European Center. Previous actions and additional funding have failed in regaining US leadership. This leads me to propose a disruptive vision for EPIC, reconsidering organizational roles, governance, and funding models. My view is that only with radical change is it realistic to expect radical improvement. Drawing from my previous experience at the European Center, I have concluded that the secret sauce fueling their success story has the following ingredients: focus, innovation, excellence, and accountability. While the US weather enterprise is often described as the uncoordinated giant plagued by fragmentation of resources, the Europeans rally behind the strength of a common goal. The success of EPIC lies in a clear, non-overlapping mission with clear responsibility and accountability. EPIC should launch a focused effort with one goal: develop the best weather prediction system for the nation. Success should be directly measured, and EPIC's directors should be held accountable. We need a center of excellence, attracting the best talents that can drive the center's goals, guide the community, and work toward operational requirements. This dream team will be supported by lean decision-making, efficiency-driven operations, and strategic allocation of resources. On this aspect, we need massive investment in high-performance computing, leveraging the elasticity of the cloud. EPIC should provide a collaborative environment where scientists from the government, academia, and the private sector can gather to conduct innovative co-development and explore high-risk, high-reward research. This requires building a research model accessible by the entire community and paired with an effective process to transfer research to operations. As EPIC focuses on encouraging and incorporating innovative science, it should also utilize an innovative business model. I am convinced that EPIC can draw from the success of the Joint Center for Satellite Data Assimilation. Its distributed structure, following a hub-and-spokes approach, increases the government's ability to engage world-class scientists and engineers. Its agile team at the intersection of multiple federal agencies is reinventing collaboration and exploring innovative pathways. In fact, the Joint Center is already applying the European secret sauce to better assimilate observations to initialize model forecasts. This major science problem is the highest priority for EPIC. I dream of EPIC as an agile center where scientists can focus on science. Red tape is reduced to a minimum, decision-making is streamlined, and community collaboration is entirely result-driven. The implementation of EPIC should be delegated to a single trusted partner that has strong connections to the community and the government, building a bridge across the valley of death. In conclusion, EPIC represents a unique opportunity. We have one shot to get it right, and business as usual is not an option. We need to reinvent the way we transition weather research to operations. The breadth and depth of the US research community is second to none. EPIC can use its ingenuity to reach and even surpass forecast improvement goals and collectively reclaim American leadership in weather modeling and prediction. Thank you for your attention. I look forward to answering any question you may have.
Thank you. At this point, we will begin our first round of questions. The chair will recognize himself for 5 minutes. I want to start by thanking you, Dr. Jacobs, for a really productive meeting we had in my office last week on NOAA and the future of weather forecasting, the role of science, the Enlightenment. We had a wide-ranging conversation. I appreciate it. And I really just want to emphasize again how much I appreciate you taking the time as we discuss in greater depth today the EPIC program and the future of the U.S. weather modeling. And I also want to make sure that we keep in mind the great work of the National Weather Service forecasters and their efforts to ensure that communities receive timely and accurate forecasts of major weather events 24/7, 365. To that end, Dr. Jacobs, I will again echo my concerns about NOAA's FY20 budget request to eliminate 110 full-time equivalents, and I just want to reiterate the ask I made in our meeting and my subsequent letter, which I will use my power as chair with unanimous consent to enter into the record, and just would ask that you follow up with the committee on the issues raised in that letter. Thank you. Dr. Jacobs, in your testimony, you discussed how once integrated into the infrastructure of NOAA, that EPIC will be used within the unified forecast system to improve the forecast skill of NOAA's other modeling initiatives, including climate and ocean models, which, as a scientist myself, I geek out on how that would all work and the idea of actually having a model that can both research and model many types of events, hydrological changes, sea level rise, fisheries, and harmful red tide. Can you help us understand what is your timeline under which EPIC can improve these other economically and ecologically important forecasts, and especially with tying in near-term weather to crucial longer-term climate models?
Sure. Thank you very much for the question. Very much appreciate the time we spent together and appreciate your interest in NOAA and numerical weather prediction. The unified forecasting system is a way to sort of streamline our production suite. Inside of the National Center for Environmental Prediction, we run a lot of different models, from high-resolution short-range convection to dynamic climate models, medium-range models, and then we have wave models, ocean models, hydrological, biological, ecological models. We're trying to get all these in a unified system. And this sort of hinges on the NCAR NOAA MOA, where we were looking at a common code base and a common infrastructure. The finite volume cube sphere FV3 dynamic core was actually originally written as a dynamic climate model, but we realized we could actually use it at higher resolutions as a weather model. What's appealing to me here is when we can unify a lot of the code architecture, then we eliminate a lot of these redundant kind of parallel development programs and have the same amount of people all focused on a unified forecasting system. The timeline is essentially, we really wanted to focus on the global model first, because the global model provides the boundary conditions for all of the other models. In other words, if you're interested in looking at a forecast for harmful algae bloom, we have biological models for that, but those models depend on a hydrological model, which models how there's runoff, and of course that depends on the weather model, which forecasts the precipitation. So the first sort of foundation of this is implementing the global model, and then all of the other models that use that for initialization will then be implemented.
And I'm sorry, just because I'm tight on time, and I want to get one more question in. And any ballpark on schedule, or is it too soon to say?
Well, we're already pretty far down the road in developing the unified forecast system. We're expecting, we've actually just had a public release of the seasonal to subseasonal version of the code. It's on GitHub now. But it's not supported yet for the community, so we're really trying to work on the model support for that. These upgrades will be coming out on GitHub as I speak. We're hoping to get the RFP for EPIC out early next year.
Okay. Dr. Masse, with the little time I have left, I want to raise with you a conversation with Dr. Jacobs, given your numerical modeling background. I sit on the AI task force on financial services, and we have this continuing conversation around, in a world of machine learning and AI, there's this trade-off between precision and accuracy and transparency of algorithms. As we build out more and more sophisticated weather models, given your background in modeling, do you see trade-offs coming in the weather forecast model as we get more precision with machine learning, but potentially start to separate from the fundamentals in the models that we've relied on that have some level of physical understanding? And is there anything that we should be concerned about as a committee if that break happens?
I don't know if concern's the right word, but I think the marriage of AI with modeling is very powerful. AI and machine learning is very powerful for quality control, but just as importantly for post-processing of model output. So you need both. You need the dynamical models, but you need machine learning on both sides. So together, they're much more powerful. Okay,
and I see I am out of time, so I now recognize Ranking Member Marshall for 5 minutes, who we have missed. Mr. Lucas, you are recognized for 5 minutes.
Thank you, Mr. Chairman. I appreciate the opportunity. And Dr. Jacobs, you've been before the panels enough times to know that occasionally we ask about the same thing, we just come at it from slightly different angles. And with that in mind and in spirit, I'd like to note that I'm concerned that NOAA may be approaching EPIC implementation as something of a software issue, where the agency views the biggest challenge to improving weather forecasting as simply improving existing software. What assurance can you give the committee that NOAA is engaging the academic community and the private sector to ensure that this is truly a community-based weather prediction model?
Well, the primary assurance I can give you is that it'll have to exist outside of NOAA. And having the involvement of industry and academia is essential. This will all be built into the request for proposals. We had a big meeting in August. We just released the report of that meeting yesterday, and we had a lot of stakeholders from all the sectors involved in contributing. So this is the whole point and design of this is a stakeholder-run program with an operational outcome that NOAA should benefit from.
Along that line, Doc, I'm a member of a body where there seems to be an ever-increasing turnover. So when I ask this in the politest of terms. What assurance can you give the committee that EPIC will continue past your tenure at NOAA?
Well, once the RFP, once it's...
And I'm not predicting the length of anyone's tenure. I'm just asking about continuality.
No, this was a top priority for me, and making sure this lives past my tenure is extremely important. And that's another reason why having it, externally managed would ensure that if it's inside of NOAA, then NOAA, has complete and total direction. If it's external, I expect that NOAA will have a seat at the table in guiding what it does, but largely driven by external stakeholders, will ensure that even if I'm not at NOAA anymore, it will still be successful.
And along that line, let's, if you could expand a little bit on your current acquisition strategy and the timeline that we're very concerned about here about implementing EPIC.
So there's the RFP, which we expect to go out early next year, first month or two, and then an additional. So there's two sort of acquisition strategies we're concerned about. One of them is where does EPIC live? That will be we'll learn that when the award goes out. Then there's the acquisition of cloud-based compute resources. This is a little bit trickier. So we have a need to procure cloud-based resources, but right now with the federal acquisition regulations, it's very complicated for us to try to figure out how to buy cloud compute on a demand that fluctuates. It's not just like buying a rack of servers.
And as an elected official, I would be remiss if I didn't ask how universities such as Oklahoma, the University of Oklahoma, would have a chance to participate in EPIC.
Well, my hope...
There are homegrown questions, you know, wherever we come from.
You know, so obviously their expertise is largely in convective weather forecasting, and there's a component of this that will deal with that weather forecasting. I would hope that they would be both contributing model improvements as well as benefiting from some model improvements, as well as the Mesonet program and all of the different observing systems. We'll be able to test those in this open cloud-based architecture, which I think will benefit not just the forecasting, but the observation systems going into the models.
And one more time, touch on what you would define as the milestones that will reflect our progress towards closing the gap with the Europeans.
So the first initial milestones of success would just be how many external stakeholders are actually using the code. So we would want to monitor how many downloads, what's the user interest, and after that we would hope that we would start to see contributions and improvements coming back. But the initial steps are just getting the external stakeholders engaged in the program.
And Dr. Masse, you're not exempt from these kind of questions either. And I asked this, and I think I know the answer, but I'm going to ask: does the broader weather research community support EPIC?
I think the answer is clearly yes. But we want EPIC to be something that does serve the entire community. That's crucial.
Thank you, Doctor. And with that, I yield back, Mr. Chairman.
Great. Thank you very much. Thank you to the witnesses for being here today. We all appreciate your attendance. The ability to forecast hurricane tracks has greatly improved since the 1960s. Forecasting hurricane intensity has also improved, but less so than the track forecasts. In fact, in 2017, Congressional Research Service reported on forecasting hurricanes found that the biggest challenge facing the National Hurricane Center is how to improve the ability to predict hurricane intensity. Being able to better predict how strong a hurricane will become, as well as when and where it will peak in intensity, is key for the district I represent along the west coast of Florida, which, as you know, is incredibly vulnerable to hurricanes year in and year out. So, Dr. Jacobs, given how costly hurricanes are to the United States, and in particular to Florida, how will EPIC improve hurricane intensity prediction, if it will?
My expectation is that it will. The focus primarily for hurricane intensity is largely centered around two things: two-way coupled modeling with an emphasis on sea surface temperature, because that's essentially the fuel, and the physics in the model. So there's a deficiency in the model physics that needs a lot of research and improvement. EPIC will essentially be the external sandbox where stakeholders can test their improvements to both the physics as well as the two-way coupling of the models. And then additionally, new observations, new observing systems. So there's a lot of new observing systems coming online, not necessarily NOAA assets, but industry assets and even academic devices that we don't have the internal bandwidth to test the impact of those OBS in our system, but we can test the impact of those observing systems in the proposed EPIC sandbox.
Great. Would any of the other witnesses care to comment on how EPIC will improve hurricane prediction? Dr. Neely?
Thank you, Mr. Christ. I think one of the critical ways in which EPIC can improve hurricane forecasting is by marriage of the unified forecast system with next generation data assimilation techniques, particularly the types of technologies that are being developed in Dr. Auligné's group. There has been some numerous scientific evidence that data assimilation, taking the observations that Acting Administrator Jacobs mentioned and using them to initialize the model, can be one of the most important aspects of getting the hurricane forecast right. EPIC, if it crafted correctly, is the cauldron in which entices all of these scientific capabilities to come together and be married to improve our weather forecasting capabilities.
Great. Thank you very much. Any others? Yes.
Let me tag along to this response. So there's multiple evidence showing that if we're looking at the quality of the forecasting, the definition of the initial conditions and the actual model are equally important, and data assimilation is handling the initial conditions for the model. So we're actually blending together observation and a previous model forecast to actually optimize these initial conditions with, due to the chaotic nature of the atmosphere, are propagating and amplifying in the forecast. So it's actually a critical component of forecast accuracy.
Great, thank you. I wanted to ask, I'm running out of time, I wanted to ask one additional question, if I might. In addition to weather forecasting, NOAA is also responsible for researching and modeling other types of environmental concerns, such as red tide and algae bloom, which, as you know, is of great interest in the Sunshine State. Dr. Jacobs, can you discuss how EPIC will help improve forecasting for red tide and other harmful algae blooms?
So, as I was explaining earlier, a lot of these harmful algae bloom models depend on the atmospheric model forecast of precipitation and runoff to determine when there will be triggers. Ultimately, we are going to put in all of these secondary downstream models, so to speak, into the EPIC program. In conjunction with this, if we have an external repository for the modeling system, as well as the code that we're running on cloud, we need to have an archive and repository for observations. And so building out our observation system in the cloud is going to be essential both for initializing and verifying the models. And that's largely what NOAA's Big Data project is focused on.
Thank you very much, Dr. Jacobs. I would now like to recognize the chair, Madam Fletcher.
Thank you, Mr. Christ, for sitting in the chair. I believe my first order of business would be to recognize Mr. Murphy for 5 minutes.
Thank you, Madam Chairman. Thank you, gentlemen, for coming this afternoon. My expertise for the weather is looking up and seeing whether I need an umbrella or not, so thank you for giving me a heads up on that. Just one actually really kind of rudimentary question. Can someone just explain to me in terms that I might understand the difference between the European models and the American models? In other words, why do we, when I look at hurricanes, I live in eastern North Carolina, so we love to do the hurricane watch. And we see the American models doing one thing and then the European models doing another thing. What's the fundamental difference between those two models?
So I'm going to try to answer this real fast and then hand it over to the rest of the panel. But the primary fundamental difference is how the European Center does data assimilation. And that's basically how they generate the initial conditions in the model. They use a true, what we call four-dimensional variational data assimilation. And right now, the NOAA modeling system uses a four-dimensional ensemble variational assimilation, but it's not they don't truly vary time as the fourth dimension.
Is he being truthful?
Yes, so the principles, the fundamental equations are the same. The way these models are implemented are quite different, like car models can be quite different, although the principle of a car is the same. So in terms of the data assimilation, there's definitely a lot of emphasis in Europe on the algorithms and the use of additional instruments and more data. So that translates into actually additional forecast skill.
All right, thank you. One other question, just in my field, just in medicine, we look forward to every new advancement and what things are going to happen. But I will ask this question, and this is, you know, an honest, hard question. What is going to be our ROI on this? In other words, where are we now, stagnant now, and if EPIC is fully instituted, how much further, how much more advanced do we truly, honestly, expect to be? In other words, what can we gain from this in implementing this system? Yes, sir, Dr. Masse.
Well, there's no reason to think the European Center is as good as we can be. American research capabilities so far exceed that of Europe as an aggregate. So our skill can be better than that. I think we could catch up within years if we just got the data assimilation right, and then over a longer period of time improve physics. I think we could be ahead of them in 3 to 4 years if we really put the energies into it.
All right, just a follow-up question, because I'm a function over form kind of guy. When we have hurricanes coming towards the East Coast, everybody acts the same. They buy their water, they get their bread. How is this going to make it any different? Again, I'm just looking, you know, I believe in research. I believe in the advancement of knowledge by all means. But how is it going to change the lives of the average American, say, on the East Coast with hurricanes?
All people make decisions in all types of weather events, whether or not it's a hurricane or a more mundane thunderstorm in the afternoon. Anytime you can make better decisions because you have better information, you're better off. There are estimates that the national economy is in the order of $1 trillion dependent on weather. And if by incrementally improving our weather forecast, if we can make that dependency down by, say, just 1%, that alone is a $10 billion payoff for our economy. I think that's the ROI that you asked for.
All right, thank you. Chairman, I'll yield back my time.
Thank you very much. I will now yield myself 5 minutes for questions, and I apologize for just arriving. As I believe my colleague, Mr. Babin, did. We were voting in another committee, but I'm really glad to be here to see all of you, and I appreciated your written testimony. I'm sorry I missed your initial comments, but I do have a couple of questions that I think haven't been covered yet. It's clear from the written testimony, the recommendations from the Environmental Information Services Working Group, that a strong, accountable, and vision-oriented leadership and management is needed to ensure EPIC's success. To my understanding, there isn't a clear plan for that leadership or management or governance at this point. And so I want to ask all of you, what are your thoughts about who should lead EPIC and how it should be structured? And Dr. Jacobs, I'd like to start with you.
So I'm going to answer this question at a very high level because really the point of EPIC is to have it governed by the weather enterprising community. So I'd be interested to hear what the weather enterprising community had to say. The request for proposals is going to have some guardrails, but part of what we're going to be asking in the RFP is also proposal of a governance structure. You know, NOAA obviously has to be involved, but we want involvement from private sector and academia. And ultimately, EPIC may end up, you know, it could be, you know, end up at a university, it could end up at UCAR, it could end up in industry, it could end up in some kind of combination of all the above. The only things that I really would like are that it's got to be external to NOAA. NOAA's got to have a seat at the table. It's got to have an operational outcome for NOAA forecasting products in mind. And other than that, a lot of the governance is going to be part of the proposal of wherever it ends up.
Thank you, Dr. Jacobs. Dr. Masse?
Well, this is going to be a community modeling system, so the community needs to be there. There needs to be at least an advisory committee that's in place. There needs to be some kind of group that encompasses all the people that are putting money into it, so that'll be there. But there needs to be leadership. One person has to be responsible. There has to be a leader, a director of EPIC, somebody who is responsible, and if it doesn't work out, heads will roll that person. So you need responsibility, 1 point of responsibility.
Thank you. Dr. Neely?
Thank you. I think the most critical characteristic of a successful epic is the breadth of the science and diversity of science that takes place in it. In order to achieve that, epic has to be crafted in a way that the scientific community is enticed to participate and is not sort of mandated or directed to participate. It is the place to go to conduct numerical weather prediction science in the world. And as such, it will create, therefore, the best numerical weather prediction science and come back to benefit of NOAA and others. Who should lead EPIC? Is the institution that is best able to create that enticing institution that brings scientists want to go to, and that's who should lead.
Thank you, Dr. Neely. Dr. Auligné?
So I think that one of the main risks for EPIC is fragmentation. We want first to make sure we have a clear focus and clear, as Dr. Masse was saying, clear accountability. We need to make sure we can define, measure success, and we can have somebody accountable for it. Then we need to have these clear connections with the community and clear connection with the government as well. So it can't be completely inside the government because we're not trying to replace NOAA. We're not trying to replace the research and the R&D in NOAA. We're trying to supplement and really help the government with more agility and more connection to the community. So that's basically what I think is required for the institution that would lead EPIC.
Okay, thank you. And I want to follow up, Dr. Masse, on your comment about leadership. There needs to be clear leadership. Do you have ideas or a vision or a thought of what that leadership should look like and where? I'm not a specific person, obviously, but sort of when we're talking about what is the structure, and I'm going to circle back to Dr. Jacobs with another question in a second, but what does that look like to you, or what should it look like in terms of that leadership?
Well, we can see that. We can see our competition, the European Center. They do have a leader, a scientific leader that oversees the whole program. That's the responsible person. But they do have an advisory board that's there as well that represents all the various countries that are involved, and they have scientific advisory committees. So they give us somewhat of a pattern of what we could follow that's been highly successful.
Okay, thank you. And Dr. Jacobs, you mentioned in your testimony about the RFPs, so I just wanted to get a follow-up on that as well to know your thoughts about sort of a dedicated staff and leadership team, and if that is something planned, and if so, when it will be announced.
So that's largely going to come out of the responses from the RFP and wherever the award goes. But to Dr. Masse's point, I think we'll probably end up finding a where we have some type of board, and then a single point person who has autonomy, accountability, and control over the budget. Some of the things that I've seen have failed in the past were run by individuals who had complete autonomy and no budget authority, so they couldn't actually execute great decisions.
Okay, thank you. That's helpful. I have managed to go over my time already, so I'm going to yield back, and I'm going to recognize Dr. Babin for 5 minutes. Thank you very much.
Thank you, Madam Chair. Appreciate it. Appreciate all of you expert witnesses for being here. Dr. Jacobs, as you know, the 36th District of Texas, over in the southeast portion, was hit especially hard by Hurricane Harvey in 2017. Additionally, Tropical Storm Imelda dumped a record amount of rainfall in my district just a few months ago in September. This storm came out of nowhere with a severity that surprised everyone and left most of my constituents without time to prepare for it. Let's jump ahead, hypothetically, just a few years into the future, where EPIC has been successfully implemented and is operating. Can you walk us through the processes of a fully functioning EPIC as the storm approaches, and how the days leading up to and immediately following a storm like Harvey or Imelda, and how that would be different?
Sure. Thank you very much for the question.
Yes, sir.
So EPIC, the fully successful EPIC will happen, pardon the pun here, but way upstream from these precipitation events. So what would happen is When you look at the National Water Center, which is a fantastic center, they got the National Water Model. It's you know, it's a very successful program. But if there is one weak link in the National Water Model, it's that we have to forecast properly where the rain's going to fall. Otherwise, we don't know where the runoff is going to go. And so having EPIC be the center where we actually feed in inputs to improve the forecast of prediction of rain will then subsequently improve the prediction in the hydrological models. So a lot of this will happen months to years in advance. But you will see the improvements of those actual forecasts find their way down into, you know, things like, you know, not just hydrological models, but also biological and ecological models as well.
Sure, okay. And I also serve as the ranking member of the Space Subcommittee here with the privilege of representing Johnson Space Center. I know the impacts that one government facility can have on an entire region. As it stands, EPIC will be a virtual center that will have tremendous benefits by operating in the cloud, both in terms of cost and innovation. Again, looking ahead to years down the road when EPIC will be running smoothly and surely will be the gold standard at that time, is there a scenario where a physical center rather than a virtual center could be beneficial to EPIC's mission?
Absolutely. So thank you for allowing me to clarify this. I have often referred to EPIC as a virtual center because EPIC, when it's listed in the budget proposal, was as $15 million. And I didn't want anyone in the budgeting process to think I was planning to actually build a brick and mortar center for only $15 million. So when we put out the RFP, EPIC will have to live somewhere. There will have to be people in seats at computers in some type of facility, whether it's a university or other, you know, other facility. There will have to be a physical center. In addition to that, if we have the opportunity to expand this program, it's entirely probable that we would need an additional physical center for this somewhere.
Right. Yes, sir. Dr. Masse.
Well, even if we're very successful at creating the best weather prediction system in the world, we're still going to need the computers. So if we don't have vastly increased computer resources, we're not going to be able to deliver the forecasts that we really want to. That's really important.
Understand. Thank you. Well said. You know, I'll yield back, Madam Chair. Thank you very much.
Thank you, Mr. Babin. And thank you to all of our witnesses. I know we just rushed in, and unfortunately, we have to go back and vote in our other committee. I'm sorry to say, but since we have all come and gone from the hearing, I really appreciate all of you coming in, testifying, sharing your thoughts. I think this is really exciting to see what's happening, and I'm grateful for all of you participating today. Before we bring the hearing to a close, I also want to mention that the record will remain open for 2 weeks for additional statements from members and any additional questions that the committee members may have for the witnesses. But for now, the witnesses are excused, and the hearing is now adjourned.